Right, time to introduce the second speaker, who's setting up in the meantime. Who's this already? So it's super nice to have mad scientists amongst us. Please raise your hands, all mad scientists. Anthony Liekens, he's been doing a lot of different things. I've been meeting him at a lot of different places. But the nicest thing that he does, he has his own hackerspace or makerspace community in his own garage in Borsbeek. Borsbeek represent. But he also teaches several courses, and he's going to share some thoughts about teaching and getting students to create IoT concepts and what the challenges there might be. Anthony, the floor is yours.
Thank you. Where's the thanks? Yeah, I'm onto it. Well, thanks for inviting me. I'm going to take a kind of a. I usually have a different approach in talking to people. First off, I don't like PowerPoints. This is also going to be a bit of the explanation of my reasoning of what we're doing. I prefer prototypes over PowerPoints. That's a very statement I'd like to make. And I like your introduction because you pointed to some education problems. I'm not going to say I've got answers to that, but I want to give you some of our approach of how we teach students in making IoT products. So I've been teaching a course which is called Design Lab. By the way, I'm a mad scientist. My background is in computer science and biology and French cuisine, not in design, so let me put that forward first. But I'm teaching this course, Design Lab, at Thomas More Mechelen, which is a college in Mechelen. And they have students, and the students are information management students, which means is that they get courses which is somewhere a mix between doing computer science or informatics, and on the other hand doing business. So they get kind of a balance between being on the stage as the CEO of the company, but also being behind the stage and working on the technicalities of doing computer projects. I'm not sure if this is a perfect education style because you're trying to mix two things and maybe you're not getting enough depth of both. But still, well, we're trying to put these students as far as possible. And in the course that I teach, we've been doing this for the last 3 years. We try and push these students to create an IoT product. An IoT product in 12 weeks. 12 weeks, we see them half a day every week. And in those 12 sessions, we try to create an IoT product with them. Let's see if I got everything. Yeah, if anybody wants a copy of my slides, you come and take a picture of this, and that's the content of my presentation there. I just put these pictures up there so you don't look boring, and I seem to be interesting to you. So we've been doing this for three years, and every year we've taken a slightly different approach in the kind of projects that we are developing with these students. It's kind of a strange idea. So what we do is, well, the main idea is that we ask these students to create a meaningful IoT product. It's kind of strange that we push this IoT in there because you see many problems and it's not always necessary to have IoT in there to find a solution for that. So we have to push them somewhat to find a problem where IoT could be a solution or could provide a solution to that. And we've been doing 3 separate concepts and contexts in which they design their IoT product. In the first year, we've been doing wearables. We had Jasna Rock, which is the new high-tech fashion queen here in Antwerp. She was part of our student team and also part of helping the other students in designing the fashion and doing something nice with the wearables. In the second year, we were working together with the city of Mechelen and we did smart cities. Sure, why not? Well, everybody's doing smart cities, so we do it as well. And in the third year, we've also taken the smart cities approach, but a bit differently. Is that my co-teacher in that course is the mayor of Buggenhout. And Buggenhout, if you're not from Flanders, you don't know it. But it's been the city of Buggenhout, or the town of Buggenhout, I don't even know if it's a city, they have been voted as the most average town in Belgium. It's well, it's kind of a stupid title to have, but so they are smack in the middle of Belgium. They have an average number of people living in the city, and on many accounts, they are an average town, which is an interesting thing to think about if you want to do smart cities. Why do you always go to the big cities and try to do stuff with the big cities? It's more interesting to take the most average town and work with the average town. They will have different problems than all these big cities, so we've been doing smart towns instead of smart cities. Having the mayor, of course, in our teaching team was very helpful in getting something meaningful out. Let's see. Okay. I want a drink. So what we try to do is, or what I try to do in my part of teaching it. So I've got a big technical background and do many different things with technology. For me, they have to build the actual IoT product or build a prototype of the IoT product. And at the end of the course, show me the prototype, show the working prototype, and see how far we can get them. Now, for these students, so they have some business management on one hand, they have some computer science on the other hand, but they are missing out on all the rest. Right? They're not designers. They don't know anything about building a physical product because they're busy on their computers, but they don't know anything about making hardware and stuff. So what we see is in order for them to get a working prototype working, is that, and this is a realization that you also mentioned, is they have to get through a lot of different components in order to get the project running. They have to tell a story, which is something they usually don't do when you're studying computer science and business. They have to do design thinking. They never heard of design thinking, so I have to bring them into that and learn them how design thinking is going, what kind of processes you have to go through in order to come from a problem and get the prototype working. They have to build hardware. They never built hardware. They never seen an Arduino. They never had a screwdriver in their hands. They never did that. But we push them to do it. It's easy, it's accessible, especially if you have some of that computer science background. It's easy to transfer all that knowledge into hardware and do something with the hardware. They have to build software, not just software in the cloud and just some JavaScript in your front end. No, you have to build software on the device. You have to build software in the cloud. You have to build a front end. You have to do the user experience. You have all these different things, all these different components that have to be in place in order to have a prototype working. They have to build a business model. We ask them to build a business model. Is this not so much in order to, well, you're gonna get a startup out of this and you're gonna earn lots of money. No, the business model is more, can you make this work? Is this financially feasible? Can you actually do this on a financial way? This is usually the thing that completely breaks them. And of course, you got a team of different people doing different things, so you need to manage these things and get through that as well. These are all different components that these people have to go through, and they usually haven't done that yet. But by getting all these components in there and trying to make a prototype by the end of the project, of course, they're gonna learn about these things, and hopefully they get some of that reality of all these different complex components that are in there that they need to put together somehow. And in the beginning of the project, in the beginning of the course, everybody is extremely excited. Yeah, we're gonna build an IT product and we're gonna see all these social problems that we can solve. We're gonna do these things. And then about 8-9 weeks into the course, it's like, fuck, we're never gonna be able to do this. We're never gonna be able to manage this. This is so many different complex things. But they get through it. They manage to do it, and get the last few weeks, you see the hopes rising up, the actual product coming together, the cloud working, the front end working, the device working, building Legos to make a nice demo out of it, and we see them doing it. But it's the major complexity of building an IoT product and all these different components that gets them completely depressed. But we're good. We managed that. I really need to drink first because I'm not used to using a microphone here. All right. So one thing, a big process through these 12 weeks is to actually do the design thinking and learn what is design thinking. And in the beginning, maybe you've seen it in one of the slides. There are some slides there where are completely packed in plastics and boxes and cardboard boxes. Oh, these guys here. And this is something that we do in the first course, the first lesson they have. We ask them the question to innovate the umbrella. This is a challenge that we give them. Try to innovate the umbrella within 1 hour. And do the whole design thinking process within 1 hour. Which means at the beginning of the 1 hour, you don't even have a problem statement. And at the end of the 1 hour, you need a prototype that actually works. So we put boxes and trash bags and everything so they can craft a little bit. And we and my co-teacher, we are like the problem owners. We've got huge problems with umbrellas. Well, if I'm carrying my smartphone and my coffee, how am I going to carry my umbrella? If I use my umbrella in the rain, it's going to be wet, and I come into the building and it's all this rain all over the place. Can we somehow solve this? We've got huge issues with umbrellas. And they managed to do quite fine in that. Within the hour, they built the most amazing improvements to an umbrella. Most of them are just a cap, but some of these guys are pretty smart at this. And one of the ideas was a solution for the rain that's falling off the umbrella. It's like, well, you know these Nescafe coffee cups? Well, we could have like a stick that's the umbrella, and you could put like a little capsule in there, and the capsule will inflate into the shape of an umbrella, so you can use it. Then you can trash this little capsule and buy more capsules, because this is a very interesting business model, as we all know. And it's those crazy things, but it's this kind of thinking that brings them into the field and brings them into design thinking. That's just the 1 hour. And then, of course, we take those lessons learned and we put them through the paces for 12 weeks and actually creating an IoT product. I'm sweating here. Jesus. I just want to highlight some of the results that these students created out of this course. Maybe you can see them in some of the slides. You see people working on a safety vest, a light yellow fluo hesje, as we call it in Dutch. And they made this for school children, just with the idea that if you're a teacher and you take all your children to go to the zoo, they all spread out, you don't know where they are, so the teacher wants to track them, wants to put some safety features on there, like an alert button where you can like alert the teacher that something is wrong, or the other way around, that the teacher can say, well, we all have to come together, we're missing out, we can track them on our cell phone, where all the students are. It's pretty fun because at the end of the course, they have to present this to a professionals jury. The jury is like the VC in there. And in that course with these guys with the safety vest, one of the jury members at the end of the course put down a couple 10,000 euros on the table. It's like, well, if you start this as a company tomorrow, I will invest in you. Something we don't often see in these educational juries, but somehow it gets real. And in getting students to combine both computer science with business and building an actual product, and seeing then the VC kind of part is like, how do we deal with this? How do we deal with a couple 10,000 euros out on the table? Can we actually do this? It's really nice that we get that kind of result out there, that they're really proving themselves that they can build these products and build these prototypes and come to a first kind of a small investment there. Some other projects that were really nice. One was called Cloud Busters, and these guys they have like, if it's raining and the drain floods in the street and so there's a problem there, they wanted to put a sensor in the drain of the, how do you call this? Where the riolering, the sewage. So the sewage comes in and it sometimes it overflows. And they build a little sensor that fits into the sewage, so they can track whether there's going to be an overflow coming up, and then help, for example, fire to call the fire department to come out and help. But there's more that can come out of this, because they are tracking the water level in the city, and they learned from the organizations that are monitoring the water levels of the rivers and stuff like that in Flanders. They know what levels the rivers are, but they don't have any data of what is happening with the water and the extra supply of water inside the cities. But by integrating the data that comes from the cities and these kinds of sensors with the data that is already known for all the rivers, we can get a better view on water management and that kind of stuff. So it's kind of interesting what they get out. The last ones, these guys were, I think it's a great idea. If you're from around and you know where Ranst is, if you drive to Ranst, there is a placard out there when you drive into the town, and that says, well, last month there have been 176 fines for driving too fast here, for speeding. That's really nice. It's like if you drive there and you pass that placard there, it's like, oh shit, last month 176 fines. I don't want to be part of this. And you get somehow conditions like let's drive slowly because they are actually turning out fines here. Although when you drive there every day, after a couple of months, you'd start to notice like it's still 176 3 months later. Nobody's actually tracking this or nobody's actually doing this, so everybody starts driving fast again. It's a simple thing that you can put into an IT product. They built this kind of thing to put it in an IT product to have sensor tracking how fast people are driving and actually visualizing it to condition people as like, we are keeping an eye on you. No, not just like you're driving too fast. No. We've seen this many cars who got a fine in the last couple of weeks. This is all bringing the students to really building something, really getting an idea of all the complexities that are there in creating an IoT product. And there's somewhat an overview I wanted to give you of our design lab. Thank you very much.
First of all, thank you. That was amazing. I'm sure there are some questions. Also, there is water in the back in case you're thirsty. It's super warm in here. You're not the only one who's thirsty. There is water in the back. So I'm happy to make a run if you are somewhere close to the wall. I'm happy to run back there and bring you some. Alex?
Do you find that the timing of the course is right? Because half a day for the whole week over 12 weeks is quite a slow pace.
Yeah, well, they have some homework in between. So the 12 weeks that we do is kind of a contact that we have with them. What we do in that afternoon session is like we start off with a stand-up session. So we try to teach them processes that are in normal agile or whatever team. So we start with a stand-up, go through the team, see how good their progress is. We need to monitor it really closely because 12 weeks is very short. Of course, they don't need to do all the manufacturing and don't do that. They have to build up a project, a prototype and do that. It's short, but it's enough. We haven't seen any of the teams not managing to get to their prototype. So 12 weeks could be enough. Yeah.
Thanks. Really interesting work. I was wondering if you kind of try to push students to develop an IoT product, or how much this is enforced. Because I get that the goal is to get them into design thinking, prototyping, coding, and so on. But
yeah, I'll take that for the recording. Yeah, so this is the kind of comment I made in the beginning. It's kind of strange that they have to build an IoT product for whatever the problem will come across, which is kind of strange. But so we have to push them, and I think the question is also, do they work on that beyond the course? Is that part of your? So in that one case where we had the safety vests, so they were offered like 30,000 euros to like, can you start tomorrow? Let's do this because it's a great idea, it's business value, and that's great. They have started that. They started looking at patenting and IP and stuff like that, and they got completely lost in that. It was in the middle of the exams. The team is like completely stressed out by all the other courses that they have to track. When they had a great opportunity, they had an opportunity to continue with that, but the stress coming from the rest of the courses somehow destroyed the idea of starting with this company. But they could have been doing that if there would have been support from the college in order to support like student entrepreneurs and stuff like that. They would have gotten great chances. But this is like 3 years ago, and now it's more common to have student entrepreneurship and to support that kind of stuff. But so there was a real potential to get an actual product out there that was meaningful as well. But yeah, other courses and the rest of their lives somehow got in the way. So that's what ended there.
Do one more? Is there one more?
Yeah, concerning the theme of the day, which is ideation for IoT, do you do any special methods to introduce IoT?
Thank you for reminding me that. Because I had to mention, and you might have seen Dries on some of the slides there, but we're using the IoT ideation cards, and Dries comes in and brings in one of the sessions of the course, is that, well, by the time they get some idea of their problem statement and what they want to solve, it's often hard, because the students have like tens of ideas, but they think everything will be fine. And Dries also probably can confirm that it's sometimes kind of hard to get not quite motivated students to get through the ideation process. But that's what we use. So we have some kind of problem statement, or they want to do something in safety of bicycles or whatever, and then we use Dries' approach in order to. I think you're going to talk about the cards later. Yeah. So we use these cards to get the students to get to a solution or some approach that they can fix their problem. Doesn't really mean that the ideation session and the end of the ideation session they get a very discrete idea of what they're going to do for the rest of the project, but at least they have some methodology. And what we see is that by the end of the project, when they're doing their pitch, we often see references to these little cards and photos of cards they make, because it somehow influences what they are doing. And it gives them some inspiration of delving a bit further than just the little problem and just their little world that they have. Yeah, that's for sure.
Thank you so much. Give it up, please, for Anthony Liekens.